you, if we are dividing two polynomials, we are always going to be able to do that and rewrite it as a quotient plus a remainder over what we are dividing by. Okay, there is always some kind of quotient. Doesn't have to come out nice, but we can divide any two polynomials. The other way, they had you on some of your homework problems rewriting it as what you started with times the quotient, or equals the quotient times what you divided by plus the remainder. We'll talk more about all of that. The big thing, though, we're going to be focusing on these remainders right now. Yesterday, the last few problems asked you to figure out if something was a zero. And if it was a zero, what did that mean? The remainder was zero. Okay, if you think about a graph, if I tell you that 2 is a zero is just another word for an x-intercept. Okay, if I ask you if something is a factor, that's just another way of asking you if it's a zero. So if x minus 2 is a factor, that means 2 is a zero, or an x-intercept. In other words, it divides evenly. There's no remainder when it divides. 0 is just the number itself. When I ask about a factor, that has the x with it. So if I said negative 5 is a 0, what would my factor be? X plus 5. Okay, that means x plus 5 divides it evenly. Okay, you get 0 as a remainder. So, two ways of doing this. Our first example, I'm going to show you two ways of solving it, and you can tell me what you like. So if I want to know if x minus 1 is a factor, what could you do? Yeah, we could do our synthetic division, couldn't we? So in the box, you put the 0, or what makes x minus 1 equal 0? 1. And then I put my coefficients. Okay, 2 comes down, multiply, you get 2, add, you get 1. So is this a factor? Yes. The remainder is 0, so it's a factor. If you get any other number, it's not a factor. Okay, that's a way of doing it. It's not too time-consuming, not too difficult. So we can certainly do that. Did anybody catch when you were reading your handout yesterday and there was a remainder theorem on there? And I told you a way to find the remainder without doing the entire synthetic.
Plugging it in?
Yes. Grab a calculator for me, guys. What would happen if you take 1 and plug it in for all of your x's up here? And it equals 0. It equals the remainder. So if all I care about is the remainder, I don't have to divide the whole thing. I can just plug my k value in, and the answer you get out is your remainder. So it's a shortcut, right? So if I wanted to see if x plus 2 is a factor, what would I plug in? Negative 2. All right, let's try that. So we have 2 times negative 2 cubed, or minus. What'd you get? Negative 27. So is that one a factor? No. My remainder would be a negative 27, so it does not divide evenly. Okay. problem like this, I want everybody to try it on their own. So I don't care which way you do it. It's probably a little bit faster just to plug in your number. But figure out if x minus 2 is a factor. 2. So whatever would make that x minus 2 equal 0. So if you plug in a 2, and you get 8. Yeah. So it is not a factor. Alright, are we good with that step, deciding if something is or isn't a factor? Next piece I want to look at. So we have done a lot of factoring in here. We started out factoring by the greatest common factor, and then if it was a quadratic, we were able to factor with box method. Sometimes we were able to do grouping, but beyond that, we do not have a method for factoring if it's beyond a square and our grouping doesn't work. That's where we are going in this chapter. We are going to start factoring any polynomial that I might give you. Okay? Today, I'm going to give you like a clue, a starting point. So I want to factor this polynomial, but I'm going to tell you 5 is 1/0 of this polynomial. So if 5 is a 0, that means 5 divides it evenly, right? If I want to reduce this polynomial, we need to start by dividing it, so we can break it down as much as possible. So what we're going to do, since I'm giving you the first 0, I'm asking you to factor it, is we are going to do synthetic division. Since 5 is the 0, that is the number that goes out in our box. And what will I get for my remainder when I do this? 0. I already told you it works, so if you don't get 0, you have made a mistake. Alright, so my 6 comes down. 30, so that's -7. How does this help me? Okay, if you put your x's in, your remainder, your constant, x and x squared, I have a quadratic now. My directions were to factor this. Can you factor a quadratic? Yes. We would have to do the box method here. So these multiply to a -18, add to a -7, so that would be -9x and +2x. So if we factor, take out 3x and 1, 2x minus 3. So we have 3x plus 1, 2x minus 3. Okay, we're close. My directions were to factor, and this looks factored. However, if I just FOIL those parentheses, I am not going to get my original one. What else do I need? That would give me the zeros, but not the factors. Kind of a hint, this was originally x cubed, so we should have 3 parentheses in our final factored form. This is 2 of them. Oops. Where'd you get that?
I don't know. I got that. I just said it.
You just said it. It sounded good. Pretty good guess. 5 is a 0. So what has to be a factor? X minus 5. That is my 3rd parenthesis. If you took all of these parentheses and multiplied them out, you would get that original polynomial. Kind of some hints, things to look for. It was an x cubed, so most likely we're going to have 3 parentheses. It would have 3 zeros. If I asked you to find the zeros, all you would have to do is set each of those parentheses equal to 0, and you would get them all. what would I need to do? I gave you the first 0. We're trying to factor all this, so we have to do synthetic. So the first 0 goes in our box. My coefficients are 2, 3 minus 2i, negative 8 minus 5i, and 3 plus 3i. So when you write your coefficients, you just leave off your x's. Alright, from here, we bring down our first number, then we multiply and add. When I multiply these, you have to distribute the 2. So 2 times 1 is 2, 2 times I is 2i. Add like terms, 3 plus 2 is 5, negative 2i and positive 2i cancel. Multiply, 5 times 1 is 5, 5 times I is 5i. When I add, negative 8 plus 5 is negative 3, negative 5i and positive 5i cancel. Negative 3 times 1 is negative 3, negative 3 plus I is negative 3i. When I add, all of that turns into 0, which we expected because I already told you that it was a 0. So if it didn't come out, then we know we made a mistake. Alright, so if we write what we have left, this is my remainder constant x and x squared. We're trying to factor, we're down to a quadratic, so we can do box method. So these multiply to a negative 6, need them to add to a positive 5. So that would be 6 and negative 1. Then if we factor, we get 2x minus 1 and x plus 3. Okay, the final factored form for my polynomial. What else do I need in here? The one that I gave you to start with. Now be a little bit careful here. When you plug those in, you always do x minus your 0, right? So if I distribute, that becomes x minus 1 minus I. You have to change the sign on both of those. And if I multiplied that whole mess out, I would get back my original problem. We're going to do one more example together, and then I'm going to have you guys try one on your own. I'm going to ask a slightly different question here. The only thing that changes is how you answer the final bit. Okay, I gave you the first 0, and I want the rest of them. Okay, all we're going to do is just like finding the factored form, but then you have to just set each parenthesis equal to 0. So it's just going to go one more step. So we start by synthetic. If I give you the 0, that is the number that goes in the box. Okay, 1 comes down, multiply, we get 3, add, we get 2. So I get x squared plus 2x plus 2. We've been going into box method after that. Is there anything that multiplies to 2 and adds to 2? No. I'm trying to find my 0. I need to figure out what makes this equal 0. If I can't factor it nicely, how else do I solve that? Quadratic formula. Well, I like it. So opposite of b, we could complete the square instead if you prefer. Plus or minus the square root. You're welcome to do that if that's easier for you. Of b squared minus 4ac AC. Our A here is 1, and our C is 2. Over 2A. I keep writing A instead of the number, and my A is 1. If you chose to complete the square, remember that's when you move the constant to the other side, so we move the -2, subtract our 2 over. You do middle term, divide by 2, and square. So 2 divided by 2 is 1, squared is 1, so you add that to each side. And this factors into x plus 1 squared equals -1, and then you can solve from there. Where we're at with the quadratic, we get the square root of 4 minus 8, so that's -4. What is the square root of -4? So then if I divide everything by 2, I get -1 plus or minus I. If you were finishing this one, you add your square root. And subtract your 1, so you get to the same point, whichever way you chose. I did not ask for the factored form. I just asked for the remaining zeros. Sorry, I already told you the 3. I'm just asking you to find the others, and we just found them. Those -1 plus I and -1 minus I were my other 2 zeros. So I would like for you to do this problem, please. So after your synthetic, did you guys get x squared plus 7x plus 12? So then we need to factor. It's a 1x squared, so you could do the shortcut. Multiply to 12 and add to 7 would be 3 and 4. Our directions here were to find the remaining zeros, not to the factored form. So I gave you the first 0. To find the others, you just set each of these equals 0. So what makes x plus 3 equal 0? And x plus 4 equal to 0? So -3 and -4 are my remaining zeros. All right. Questions? Okay, so here's the thing though. On all these problems, we were able to do it because I gave you a starting point, right? I gave you the first 0. So the next piece, I'm going to introduce this part today. We'll keep working with it tomorrow. It tells us what to do if I don't give you the first one. So there is a rational zeros theorem. It says if you have a polynomial with all integer coefficients, so no fractions or decimals for your coefficients, then every possible 0, so these are the things that might work, will be of the form P over Q. P is a factor of the constant, Q is a factor of the leading coefficient. Okay, that sounds really confusing. It's not quite so bad, but it's easiest for me to explain this with an example, if that's okay. So I want to take this polynomial. To find everything that could be a 0, we have to find our P's and our Q's. The P value is everything that is a factor of the constant. So what is every number that divides 6 evenly? 2, 3, 1, and 6. Now I'm trying to get a -6. So couldn't I get that with a -1 and a +6, or a +1 and a -6? So can we agree that every one of these numbers could be positive or negative and it would still divide evenly? Okay. That will always be the case, so what we're going to have to do, we write out all these P's. I just prefer to put plus and minus. So plus or minus 1, plus and minus 6, plus and minus 2, plus and minus 3. That's everything that would divide the 6 without giving me a remainder. Now my q value comes from where? Leading coefficient. So for the q, we look here at this 2. Now, I can get 2 by doing 1 times 2 or negative 1 times negative 2, right? So again, we have the plus and minus. The only things that divide 2 evenly are 1 and 2. My possible zeros. Those are p over q. So I have to take every p divided by every q. Now again, we could have any combinations of signs, so every time it'll always have the plus and minus, but I do expect you to write it. Even though they all have it, you do need to write it. So 1 over 1 is 1. 1 over 2. 6 over 1 is 6. 6 divided by 2 is 3. 2 divided by 1 is 2. 2 divided by 2 is 1. That's already on my list, so I don't have to write it again. 3 divided by 1 is 3. And that was already on my list, so I don't need it again. And then 3 divided by 2 is 3 halves. Okay, does that mean that every one of those numbers is a zero of my function? No. How many zeros should this function have? 3. The degree tells you how many will work. These are the ones that could work. Okay? So now we have to figure out which one does. You're trying to get that starting point that I was giving you on the other problems. So as soon as we can figure out one number that works, we can jump right in with our synthetic division. Now there are different ways to find that number that works. We know that if it's a 0, when you plug it in, what should you get out? 0. So you can just start plugging these numbers into your function until you find one that equals 0. And that will work. That can be time consuming, but it will narrow it down for us. Another option, we have a graphing calculator. So we could use that. So if I wanted to graph this, I have 2x to the third plus 11x squared minus 7x plus or minus 6. Okay. Now, here's my disclaimer. I am fully aware that you can use your calculator to get all of the zeros. I know that. But I am teaching you a process. So you guys have to do it this way. You have to learn this process. Okay? I'm giving you guys nice numbers where the zeros are going to be fairly obvious from the graph, but that is not the case on every possible problem. So we're picking some nice ones to start with, but I still expect work. If I gave you a problem like this is like a 12-point question. If all you do is write down a final answer, you just lost 11 out of those 12 points. Okay, so I want work on these. When I look at this, when I'm looking for the first 0, where do I look on my graph? Yeah, you want something that touches the x-axis. Okay, preferably a nice number. I try to avoid using those fractions if we can. It's not the end of the world if we have to use them, but it does make things a little bit trickier. So can you tell for sure a number that hits the x-axis? 1. Do a quick check. If you plug 1 in, you get 2 plus 11 minus 7 minus 6. Does it work out? Yes. So you just found your first 0. Once we have that first 0, then we're back to where we started on all of those other problems. And so we're ready to do synthetic. So 2 times 2. what do I want from here? What do we need to do? We can do box method once we get to this point. So two numbers that multiply to 12 and add to 13. We get 2x plus 1, x plus 6. So look at all the questions I asked you. First thing, I wanted the potential zeros, the possible zeros. So we answered that. Here's everything that could be a zero. Then I want the real zeros and the factored form. Is this my complete factored form? No. What else do I need in there? Since 1 was a 0, we should have x minus 1 as a factor. Okay, that's my factored form. If I want all the zeros, we set each of those equal to 0. We get -1/2, -6, and +1. Were all of those on my list of possible zeros? Yes. So we listed everything that could be a 0, we factored it, and then we found all of the real zeros. Any questions there? Do we want to do another example, or do I want to stop for today? Stop here. You guys don't want to move on.